You will see during this event a number of applications of SWIM which are not just European ones. They are really through a worldwide approach, and this is really as well the spirit of what SWIM is about, to bring people together, to bring the aviation community together from around the world.
The SWIM concept neither prescribes nor expects a single global application. Instead, the concept allows for a standard implementation of specific components when and where required.
These two demonstrations showcase SWIM's benefits from a business, operational, and technical perspective. Furthermore, they validate the ICAO SWIM concept of operations through actual global SWIM service development, including the SWIM registry.
The GCAO recognizes from experience that participating in the SWIM global demo, as well as its involvement in the many global tour demonstration a few weeks ago, that it is necessary to make SWIM a key element in our ATM system landscape.
The lessons that we learn in these global demonstrations are invaluable for air services, to understand not only how the technology changes will influence the future organization, but also the new skill sets that our staff will need in future, and demonstrate the business value in the new services that we can add to our customers.
We foresee in short term the possibility to apply the same methods of this demonstration to establish a real data flight information exchange process between the SEA and Eurocontrol for ATFM purposes.
This started quite some time ago already with the definition phase. We are just ending the first research phase and moving towards deployment, and at the same time, as Florian already mentioned, also launching the next research program. We have been using ICAO terms for all the stakeholders as well. So this is taken from the GATMOC, the Global ATM Operational Concept. So SWIM is an enabler because it makes it easier to connect all these stakeholders. When information is being exchanged or when there is collaborative decision making, both the sender and the receiver need to have the same language, understand the same concept. So trust has two elements in it. So one is trust that if the information is given to the SWIM network, that it's not being abused. And the second one is that if you take information out, that you can rely on that information. And I think this is one of the biggest challenges that we have when we are challenging the whole world to demonstrate global interoperability, is that we're testing the standards that we have developed, most of them already at the global level, not all of them, and we're actually now in the process of testing how far we are apart, and that is also lessons learned that we feed back later into ICAO. So if you combine the technical data format and a logical service definition with, and that's the last part, the common protocols, which is what we call the SWIM technical infrastructure profile, then you have a binding of those three things. We unambiguously define how to implement a service.
We look at the flight from Sydney to Dubai, and we call it Qantas 999er. As in the demo we looked at yesterday, Qantas flight operations subscribes to the MET services through Publish Subscribe. The MET data for Sydney, METAR and TAF is published by the Australian Bureau of Meteorology and delivered via Air Services Australia. In addition to the METAR and TAFs that we will now look out, we have also a SIGMET. Here is the Dubai METAR. We have this, okay, looking at the Dubai METAR, we get the information when pointing at it, as we have seen before. We also have a METAR for Abu Dhabi, the alternate. There is actually some wind there, where there is no wind in Dubai, as you can see. In addition to METAR and TAF, there is also a SIGMET, as I said, and there are two NOTAMs published that could affect the flight. The NOTAMs are provided by IDS, who is a provider of aeronautical information. You may have met them in the showcases. If we look at the D NOTAMs, we here see how the provider is publishing the first NOTAM. He is selecting and he is submitting query for the NOTAM, some processing time, and here we have the NOTAM, and it's the type NavAid unserviceable, so it's not working. The navigational aid is not working. It's a DME called Mike Echo Kilo. Okay, let's make a comparison on Jumpstart. We should center in and see if we have the same NOTAM in Jumpstart. Yes, here we are. Mike Echo Kilo, Mikatara, and it's unserviceable. In this case, the Metra and TUF does not present any planning problems. The SIGMET could possibly affect the flight when executed, but the dispatcher assesses that the flight will descend below the turbulence in Dubai. Remember, it was from 26,000 to 35,000. So it has no direct impact on the flight. The unserviceable NavAid does not seem to pose a constraint. Regarding the special activity area, it remains to be seen. And as we can see here, when the first optimal route is published, it goes straight through the activity area. So we have to make a new query for a flight plan that goes around it. The operator of Jumpstart, could you please show the live surveillance data again? Here we are. All these tracks are actually live flights going on in Australia right now. Next, Qantas Flight Operations Center uploads the briefing information to the aircraft EFBs. And here it's demonstrated as first by Frequentis IDBS acting as the Flight Operations Center, and then Honeywell acting as the EFB. This is the Flight Operations Center by Frequentis, the EFB of Honeywell, and here we have the EFB of Thales Toplink. While browsing through the information, the dispatcher becomes aware that in Dubai FIR there is a SIGMET. We have seen the same SIGMET before. Now here is the navigational aid that's unserviceable, and we also have the restricted area. On the aircraft, the pilot selects the flight. And this is what it looks like in the EFB. And as I said, Honeywell points out that it's a prototype. We have the NOTAMs, as we have seen them before. We have the SIGMET. Even in the EFB, the pilots can point it out and get the details of the EFB. We have the Qantas 999er, which is now airborne, have departed at 7:38. So let's go to the viewer of the tracks. If we zoom in, this is generated by a track generator. So they ask for an altitude change, receive a clearance, and climb to flight level 380. Now Air Services Australia publishes a flight profile update, and the change to the flight plan now includes the updated altitude flight level 380. So we can see, pointed out by the operator, that the aircraft has now climbed to, it's really hard for you to see, but it says F380 in the route flight plan, field 15 of the ICAO flight plan. It's time for another great leap in the Swim Beamer, and this time we end up on the United Arab Emirates FIR border. Well, here, the Sheikh Zayed Air Navigation Center publishes a flight profile update in FIXM format on a SWIM network. And Jumpstart is here showing the updated position and detailed information. We can point it out. The aircraft is airborne. The TTA is 2137. The arrival message is published by Dubai Airport Tower, and we can see that Qantas FOC immediately receives the landing notification when the arrival message has been published. The real flight was conducted by Emirates Airlines, and we will be showing some documentaries from that flight. So he goes on to plot the vertical profile. Here we are, red constraint, but you see this vertical airspace area is not constrained. So the flight can climb through there, up, follow its cruise level. It goes above the restricted area before landing. It's not Emirates that does this. It's the Sheikh Zayed Air Navigation Center that does the slot swapping.
Level 300, Vuvok 290 above Emirates 127. Do you have any turbulence report in your sector?
It's 127 again, you're lost.
Yeah, do you have any turbulence report in your sector?
It's 127, you will be the first to report.
Here we see the operator zooming in. Emirates flights are moving, and this data is coming from the network manager in XML format, not quite FIXM format, but XML. Here, the operator selected the icing med overlays. So all of these are icing areas. Several months ago, when we created the scenario for the simulated flight, we said that let's have some icing conditions over Vienna to have a SIGMET to work with. So we said so, and we did. And actually, when the actual flight was flown, there was icing conditions almost at the same levels that we have predicted. That's a good sign, isn't it? We go to Vienna and look at the METAR. The wind direction is from northeast, and the wind speed is 3 knots. And this DNOTAM is of the type route closure that we have come across before. So it's now being published by GCAA. You can see it's being published here. And this is what the operator is doing in Dubai right now. The first route evaluation encounters a problem. An initial part of the route is closed by the DNOTAM we just looked at. Here it is. A new iteration of route evaluation is performed. And the second try should be more successful, hopefully. Here we can see it on Jumpstart, a more westerly route. And here it comes on the Boeing Fleet Manager on a more westerly route.
And this is UA127 Bravo, and it's coming from the network manager.
Yes. So we have an outside view of the aircraft. We have an inside view from the cockpit, and we have a tracking from high altitude. So there we are. Let's say Emirates 127, cleared for takeoff. Now, pilot advances the throttles to takeoff thrust, releases the brakes. We should be seeing speed starts to increase. We can see the aircraft starting to roll along the runway. Oh, it's some lagging there. There we are passing V1, and it's taken off. Liftoff. There's a real lag in this one. Here we can see the tracks down along the runway. We can see in the flight list for the network manager, the departure message has been sent. It's airborne at 8:28. Could that be it? When closing in on Vienna before top of descent, there is yet another SIGMET published. Also this time the SIGMET concerns thunderstorms. Here we can see, should be coming up, not yet there. Here comes the new SIGMET. This is thunderstorms from ground up to 40,000 feet, and our flight plan goes straight to that area. No good. We can see it in the Boeing Fleet Manager as well, going straight through. The network manager says that the ETA is 10:10. 10:10. Okay, this is UTC. Michael?
10.
You have a good memory. I don't. 10:10. Please remember that time. Okay. That's our ETA. Okay? Now the pilots construct a reroute on the FMS. So, we will see the operator constructing a reroute around the SIGMET on the FMS. The operator has constructed a new route. He will execute it. There it's executed. And when it's executed, it's published, and it should be received by the Flight Operations Center, who will update its flight plan. Here it comes. Now the new flight plan avoiding the SIGMET. And of course this takes longer time, so we should have a new ETA. And since it's published there, it should be received by the network manager. And look here, even though you can't read it, it says the new ETA is 10:16 compared to
10:10.
Here is the Jeppesen EFB, and we can see that it has received in the NOTAM. It's runway 1634 closure. Okay, so we have shown that as well. And now we finish off this scenario in style with a super smooth landing, Emirates style, and the usual arrival message published by Vienna Tower and received by the network manager. Landing is completed. Actual arrival time 10:41. Thank you, ladies and gentlemen, for your time, and I hope you enjoyed the show.
What we challenged here is those that had solutions building on these SWIM principles to showcase it here. Some of those showcases are actually related to the demonstrations which we see here in the main conference room.
It's really a pleasure to see something that looks like a pipe dream some years ago to start being something that you can then actually touch and take advantage of it.
And from our point of view is that thanks to SWIM we could touch many industry we were not working with, mainly, for example, Boeing or Eurocontrol. We've been working with Italian company, with Airbus Defence and Space, and I would say 5 years ago it would not have been possible to collaborate so directly, almost in a plug-and-play type of functioning with them.
If everyone equally unhappy, I think we very collaborate, right? So if one group is very happy, the other group unhappy, we're not collaborating. So sometimes collaborating is mean sharing and giving up some sort of thing for the common good.
I mean, it takes 1 month for them to consume our service. It's really short. So
the business rules exist, ICAO provisions,
what is derived from that and regional extensions, but they are not captured in a machine manageable way.
The passenger in seat 67K knows more and with more accuracy where his flight is going and what time he'll arrive at than the air traffic controller who's going to receive the aircraft in 2 or 3 hours.
We agreed on SWIM as the global name. We started working on that, and we are now 20 years later, so that's not bad for, it's only 3 reverse dog years, so we're finally getting there.
But if we actually organized ourselves, where one organization or a few provided those capabilities on behalf of all of us, we could defragment and build a more cost-effective ATM system.
And this is where we are in aviation. We are kind of that every flight event is still a surprise.
That while we feel we're a very large industry, we're really not. I mean, we're a small industry, very important, but small industry, so we do have to follow other people.
Comparing within Asia, Europe, and North America, yeah, Asia, it's quite complicated.
Go to the southeast of Europe. The capacities are half to 2/3 of that. Why? Because of the unpredictability of the traffic. I want to regulate you when you're coming from Dubai to London.
Please don't.
And
even if there were many examples in the showcase where the SNA showed what they do with SWIM, there is much more that is not swimmed in the SNA than what is swimmed. We got a lot of things that are swimmable.
We should standardize things, but regulation is, well, we need to be very, very careful with all that.
I think that what we're going to see is third parties, industry, or maybe SESAR will do it for Europe. You'll have a third party out there that'll subscribe and manage the authorizations and the access controls, and you won't let anybody come through your firewall.
And it's up to us, all of us, to demonstrate and to engage us, let's say, to bring this to the people in operation.
So I guess for here we've got a rock solid basis. On services, we are not there yet.
And the idea was to first take an example and practice, work out how we can standardize a service.
But the applications that most of the stakeholders are using will be done by third parties because we've freed the information. And I think the self-certification is going to be the most important part here.
But it's time to get there because I think we're at the end. Well, it's not really the end, huh? It's the end of the beginning.
In general terms, benefits of improved sharing of network and flight information, and I think really relevant, not only pre-flight but also during flight execution. That is recognized as being relevant. Automated filtering, alerting, visualizations, I think we've all seen that over the last couple of demonstrations. It's clearly showing the ease of accessing information. There is some metadata still missing to follow the entire trace of where is the data coming from, who has processed it, how reliable is the data. Some issues with unique identifiers, which is both the case actually for flight information in FIXM with the Goofy as well as in AIXM with the UUID, that those identifiers were not always as unique as they were supposed to be. We had on the one side the FAA with a very centralized approach on accessing information, whereas in Europe we had a very federated approach, and yet we made it work. In order to have everyone using this same standard, so it's the XMX and FIXM web services, either SOAP or REST or the AMQP, meant that for a number of providers, different transformation services had to be built. And that leads to the question, like, how do we deal with that in a deployment environment? Who is owning the transformation services? There is a need to look further into security aspects of information exchanges and distinguish between network security, transport level security, message level security, access management business rules, and in the end ensure that we have good end-to-end security. It's in the end all about trust. So if the data is just out there for anyone to take advantage of that or abuse that information, it's not going to happen. So we need to ensure that this access management is really trustable. And that also picks into end-to-end security.